Hello, 8th graders. This is Module 4, Problem Sets for Lesson 7. This lesson was about equations that have variables on both sides and determining if there was just one single solution for that, if there's infinite number of solutions, if there were no solutions at all. So that's what we're going to be looking at today. So number 1 says, give a brief explanation to what kind of solution you expect the linear equation. Okay, so they said to transform or simplify the equation into a simpler form. And we don't have to totally solve it. We can get to a point just to determine if it's going to have one solution, no solutions, or infinite solutions. So if we look at this right now, we can do distributive property, right? So we have 18, going to bring down the 18x plus 1/2 equals, now I got to go 6 times 3, so that is 18x. And then 6 times 25 is 150. Well, I'm looking at this right now. If I have 18x and I add half to it, would that be the same as having that same 18x and adding 150 to it? I don't think there's any number x where if one time we add a half and another time we add 150 and we get the same answer both times. So I'm going to assume right now that this is going to be no solutions. But just to guarantee that, let's go back. First we did our distributive property. There's no like terms to combine, so let's get our variable on one side. So our variable is 18x. So you subtract 18x on both sides. And we ended up with 1/2 equals 150. We know that's not true. Therefore, there are no solutions. And like I said, we kind of knew that already because we had the same number of variables on each side, but we're adding different amounts. So that's never going to work. Number 2, they want us to give a brief explanation as to what kind of solution we'll have here. So here we don't have the distributive property, but we do have combining like terms. So over here we have the 8 minus 9x equals, let's do it over here, 15x and 3x is 18x plus 7. Well, it does not look like we have the same number of x's. So this tells me that we don't have the equal number of variables of x's on both sides. So I think we're going to have just one solution, but let's show that. Here we have to first get rid of our variables on one side. So we get rid of the variable with the smallest coefficient, which is the -9 as compared to the 18, -9 smaller. So to get rid of the -9, we're going to add 9x to both sides. And we get 8 equals 27x plus 7. And then we undo our addition or subtraction. So they're adding 7, so we're going to subtract 7. 27x equals 1. And then we undo our multiplication or division. So we divide by 27. And x equals 1 over 27. And like we said, because there were a different number of the variables on each side, we were going to get one solution. Let's go on to problem number 3. We need to decide what type of solution this is. One solution, no solutions, or infinite solutions. Let's start with our distributive property. So we got to distribute the 5. So we have 5x and 5 times 9 is 45, equals 5x plus 45. Oh, well, these are equal. These are exact same things. So I think no matter what I make x, if I make x 2, it's going to be 2 here, so we have 10 plus 45 and 10 plus 45. If I make x 100, we'd have 500 plus 45 and 500 plus 45. So no matter what we make x be, it is going to work. So this is going to be infinite solutions because they are the exact same problems on both sides. Problem number 4, they want us to give examples of equations that have a unique solution, okay, meaning one solution. So we need to come up with examples of that. So we know for it to be a unique solution, we have to have different number of variables on each side. So I could have 3x plus 7 equals 2x plus 1. Different number of variables on each side, therefore we're going to have a unique solution. Let's do something with the distributive property. 4 times 2x minus 1 equals 7x plus 6. This is going to end up with being 8x here, and 8x is different than 7x, so we don't have the same number of variables on both sides, so it'll be unique. One more, let's try 4x plus 7 plus 3x equals 2 times 3x minus 2. Let's try this one. Let's add these together. We get 7x plus 7 equals, distributive property here, 6x minus 2 times negative 2 is minus 4. Different variables, right? Problem number 5 says to solve one of these that we did. So let's solve this one just to prove that it's unique. First thing we need to do now is to get our variables on one side. We get rid of the one with the smallest coefficient, which would be the 6x. So we're going to minus 6x on both sides. We're going to end up with 1x, but we're going to have that 1 be invisible. Plus 7 equals negative 4. Now we get rid of our addition or subtraction. Our multiplication or division. So we're going to get rid of our adding. So we're going to subtract 7 from both sides. And x equals, remember we're at negative 4 and we're going down 7 more. So we're going further down the number line. So this is going to be negative 11. And this does give us one unique problem. One unique solution, I should say. So that was problem 4 and 5, which asked us to solve one of the ones from problem 4. Problem number 6, they want us to give us some problems where there's no solutions. Remember, if you have the same number of variables on both sides, but you're not doing the same thing to it, you're not adding or subtracting the same amount to it, you're not going to have any solutions. So an example of something with no solutions would be 3x plus 4 equals 3x minus 2. There's nothing you can get for x here that'll make this true. A way you can do it with the distributor property, 2 times x minus 4 equals 2x plus 7. Right? This is going to end up with our distributor property being 2x minus 8 equals 2x plus 7. We're starting with the same number, 2x. Here we're subtracting from it. Here we're adding to it. There's no way this will ever be true. So this is no solutions. Another one with no solutions. Let's say 2x plus 3 plus 3x equals 5 times x minus 3. Okay. Now, number 7 says, once again, to solve one of these. So we're going to work on solving this to prove that there's no solutions. So 2x plus 3x would be 5x. Combine our like terms, plus 3. Here we have to do the distributive property. We're going to get 5x and a negative 15. 5x plus 3, 5x minus 15. That's not going to work. To prove it, let's get rid of the 5x on both sides. And we get 3 equals negative 15. Not true. Not true. Therefore, no solutions. Just like we thought. And numbers, so that was 6 and 7. Attempting to solve one of those from 6. Problem number 8. Solutions where there's, give equations where there's infinite solutions. So if you have the exact same problem, the same number of variables, and you're adding or subtracting the same amount to it, you're adding the number you pick for that variable is going to work. So if I have 3x plus 5 equals 3x plus 5, you're going to have an infinite number of solutions. Any number you pick for x is going to make this true. You want, you can pause the video, try 3 or 4 different numbers, see if it was right, but it should always be true. Another one, let's do, use the distributive property. 4 times 3x plus 2 equals 12x plus 8. They don't look the same, but do your distributive property. You're going to get 12x plus 8 equals 12x plus 8. Any number is going to work. Let's do another one. X plus 4 plus 3x equals 4 times x plus 1. Now, number 9 says to solve one of these to prove that we have an infinite solution. So let's work on this one. First, do our distributive property. We get 4x plus 4. Here, combine your like terms. 4x plus 4, right? They look the same. We know it's infinite solutions. But let's go and finish solving it. So we need to get rid of our variables on both sides. So we got to get rid of the 4x here and the 4x here. We end up with 4 equals 4. We know that this is true. 4 does equal 4. Therefore, we have infinite solutions. Remember, you can always email me, call me through Teams, chat with me through Teams if you have any questions. Have a great day.